Hello everyone, today we will be sharing about CAN communication. It is a type of controller area network, a serial communication protocol specifically designed for automotive and industrial control applications, which is widely used in various real-time control fields. Originally developed by the Bosch in the 1980s, the CAN communication protocol has been standardized as ISO 11898, so far used in automotive electronics, medical devices, building automation, and such. Let's take a look at the functional features of CAN communication. There are 5 parts about it: its reliability, real-time response, multi-master mode, short frame structure, and low cost. The CAN protocol has strong mechanisms of anti-interference and error detection for communication stability in noisy environments, so it is suitable for applications with rigid requirements. CAN communication supports priority transmission, so the higher the priority of the data frame, the shorter its waiting time, enabling the system to respond quickly to emergencies. And CAN uses a multi-master bus structure, where each node can actively send data. And it supports direct communication between nodes without coordination from the central controller, so that flexibility and fault tolerance of the system is enhanced. CAN has a short data frame with up to 8 bytes of data, which is conducive to rapid transmission and less data latency, so that it delivers more real-time data transfer. Simple hardware and low cable cost on CAN allows it suitable for large-scale use, especially automotive and industrial automation fields. Next, let's make a simple configuration using one VC5 PLC and one SD700C, a servo drive, and the programming software AutoStudio. Please note that PLC servo drive connection and motor control via the PLC should be normal. Next, the wiring. Connect the PLC and servo drive with an Ethernet cable, one end to the CN6AE on the servo drive, and the other side can be cut or used for PAN1 and PAN1 related settings with relative adapters. Set PN000 equals 1 for position mode, PN080 equals 1 for the local servo address, PN083 equals 5 for 500K baud rate, PN208 equals for Conopin mode on the servo drive. Here is the program configuration. We can find the CAN through the status tree on the left, double-click to set up the master and configure the slave. On the right, we can edit to commands in the main program, one for axis enable and one for jogging. Let's open AutoStudio for a program demonstration. Create a new project and select VC5. Name it to CAN. Double-click to open the CAN project. Select Master. And then 500. Remember to keep the parameters consistent with the slave. Then select CAN and right-click to add config table. And double-click to open it. Add the SD700 EDS file by double-clicking on it. The station number is 1. And keep other parameters at default. PDO mapping is already integrated, so keep the default. We can select and add control and status words if necessary, but we won't do this here. Choose to quick monitor here. Below is a network port node, and we can see that communication is normal. Next, let's create a new project. Click on Conopin on the right to perform the MIC power, the axis enable command. Select 1, and then associate status with M1, and error code with D100. This is the power command. Next, we will do a jog command. Select M2. Axis number 1. Forward M3 and reverse M4. Associate speed with D10. An error code with D101. Then we will add a read position command. Select M0. Axis number 1. D14. Compile it and there is no error. Select the Ethernet port and click Search PLC and OK. Download the program into it. And then click Monitor, and we see that the access status has no errors. Enable it. And it's done. Set a speed. And an acceleration. Enable the jog function block. And click on M3. We can see that the position is decreasing at the speed of 100. Next, disconnect M3 for a reverse operation. Select motor M4. And the axis runs successfully without errors. This concludes today's sharing. Thank you all for watching.